Hi guys, it's Mrs. Moss here, and we're going to continue our discussion on erosion and looking at the different agents of erosion. Now in the previous video, we looked a lot at water as the primary agent of erosion. Let's go into some of the others. Our next one is glaciers. So what are glaciers? It's a really cool picture of one there. How would you define them? Well, when more snow in the winter accumulates then melts, in the summer, the snow at the bottom turns into ice. And if it becomes thick enough, its weight will cause it to move under the pull of gravity, and the glacier will advance forward. When the climate warms up and the ice melts, then the glacier retreats. So really, glaciers are the accumulation of snow and turning into ice, and more snow occurring and ice staying there than it is melting. Now, a continental glacier covers an entire continent. This is a picture of Greenland, and notice it looks like a sheet of ice. That's because it's a continental glacier. This is a picture of an advancing glacier. A valley glacier moves within a valley. This is very different from the continental glacier, where the whole entire continent is covered. In a valley glacier, it just moves, the ice develops within a valley. Here's a picture of a glacier that's advancing at the top, and you can see that as it accumulates, it spreads out along this whole valley. But then when it retreats, you notice that it's gone back up into the mountain area. Now, we had an ice age many years ago, and when extensive glaciation occurs, an ice age can happen. The last one was around 12,000 years ago. And here we have Greenland's ice, continental ice, and it just expanded and advanced down into the United States. Now, small sediments are carried by a glacier. And what will happen then is they actually rub against the ground rock surface below it, and it will smooth and polish that rock surface below it. Larger sediments get picked up and get carried in the glacier, and so those will scratch or striate the rock surface below. So actually, moving ice and glaciers can pick up many sized sediments and carry it along. It can smooth and polish or scratch and striate the rock surfaces below. Here's a picture of a rock that, if you notice along the center of it, it has these scratches and striations that I'm talking about. That's evidence that it was picked up and moved by a glacier, or that a glacier had come over that. Here's another picture of rocks. And you notice there's a pickaxe right in the middle. That's just really there to give you a size scale of how large this is. But you do see the striations and scratches along this rock surface, indicating that there's a glacier once there. Now, these glacier striations can also indicate which way the glacier retreated or advanced. And this is a picture of some rock that has been polished and striated by a glacier. Now, as I mentioned before, glacial movement can bring all sorts of sized sediments. So we say that the sediments within a glacier are unsorted because there's no organization to them. They're not arranged by size or by shape. They're unsorted. It comes and it takes everything in its path, or it can leave behind the same unsorted sediments. Here's a picture of a glacial till. This is what was left over from a glacier, and you notice that there's larger sediments and there's smaller sediments. So this is evidence that this was left here by a glacier. Again, another picture of unsorted sediments. Now, those unsorted sediments that are left behind, if they're very large in size, we call that a glacial erratic. It's like a random rock that it just seems like, where did it come from, right? You may see these at places around New York, like Yankee Stadium, Central Park, the zoo, the Bronx Zoo. They're very common to see these huge rocks in those areas, and they're all evidence that a glacier had come down and helped develop this land. Again, they're large rocks that have been transported by glacial ice without being broken up into small pieces. Now, just as rivers create V-shaped valleys, glaciers create U-shaped valleys when they come through. So you'll notice the difference in a valley. If it was formed by a glacier, it will create this U-shaped valley. And here is the U-shape. It's less pointy and less pronounced than a V-shaped valley. And just as with a straight stream, the glacier's velocity occurs fastest in the center of where the valley is. Now, glaciers have shaped landscapes, and they actually create formations within that landscapes. We're going to talk about this more in detail in a later unit, but just for the sake of discussion now, since we're learning about glacier and glacier movement of sediments, you can see here from this picture as a glacier came down from this mountain, it left behind what's called an escarpment and a horn, which is a sharp peak. It also had come down into this valley, and we know that because it's a U-shaped valley. So there are definitely certain features within a landscape that we can tell has been created by a glacier. So to summarize, glaciers act as bulldozers, and they pick up everything in their paths. They polish and striate or scratch the bedrock as they move. As more snow falls, the glaciers advance, and as it melts, they retreat. And when they retreat, they deposit unsorted sediments, sometimes known as erratics. They also carve out U-shaped valleys, and they deposit the unsorted sediments all along those U-shaped valleys. Now, there are two other types of erosion. Now, wind erosion occurs primarily in dry climates, and it is eroded particles that get pulled by the air and carried to another location. You could see it occurring just along the top of the surface in this dry area here. This is wind picking up the sediments and bringing it to another location. The eroded particles are sorted by size. Now you could tell something has been created by wind erosion because it has certain characteristics. The rock surface will be frosted or pitted. And if you can see these little holes, that they look like this is really a rough texture to touch, almost like a golf ball has those divots inside the ball. That's what wind-blown sediments have. They have those little pits, and we also call it frosted texture. Excuse me, let's go back. You also see it has this slant on it. This would indicate that the wind came from this direction and blew into the rock this way, creating this slant in the rock. So again, depending on the direction of where the wind is coming from, it will pick up sediments and pelt it against another piece of sediment, eventually chipping away, leaving behind a slanted rock, which we consider to be a ventifact. It will also create pits or grooves in the surface of that rock. So again, this is a picture of just how the wind will leave behind a ventifact, or a piece of rock that has been broken from wind erosion. Here's a picture of desert storm sand, and this is exactly how wind erosion occurs. And this is just formations of what had happened and how what it leaves behind. This huge formations from wind erosion. You could see the pitted surface, and you could see the ventifact that it left behind. Our last discussion of agents of erosion is gravity. Now, gravity we mentioned in our previous picture, in our previous video, and that is how gravity, the force of gravity, will pull on the ground or pull on the sediments, causing it to go downhill. And we see this with landslides and avalanches. I'll show you some picture of those in a moment. But what you need to realize is that this happens very quickly. Gravity occurs fast and will pull that rock and those sediments down fast, leaving it sharp and angular. Again, the fallen rock is sharp and angular, and here's a picture of how a landslide and gravity acted upon this land and covered the street. This is also known as mass movement because the mass of land. Now here's a picture of a landslide, and you can see just how forceful this is because of all the debris that's being picked up and carried down the hill with it. It's happening very fast. And here's an avalanche occurring in the snowy regions, and the same type of thing happens. The snow gets forced downward from gravity, and it's such a huge force that it really can actually damage areas, and if you're caught in that, you could possibly be killed. Like this poor car got stuck in an avalanche, and now you can see it's tumbling over, and there goes its tire. So that ends erosion. We're going to talk more about the opposite process called deposition in another video. But for right now, that's enough for erosion. We'll talk to you next time. Make sure you get those notes down and have a great day.